So as we have seen the solution using a core API, now let us also get the solution using DataFrame. For this problem statement of getting monthly crime count by type, as the data have the structure, and also our problem statement is primarily can be expressible using SQL. We can actually convert the data to DataFrame, and then we can run SQL around it. And while converting the DataFrame, if we actually limit the conversion of DataFrame to the fields we need, then the side effects of other fields will be lesser. So for that reason, let me extract the date and the primary type from the input data, and then convert into DataFrame, write SQL around it, and come up with the final solution. So here I copy pasted the data which I have used earlier to read the data from the file system and remove the header. Once that is done, I am converting into this data into DataFrame with name crime data with date and type df. So this is my variable name, just to make sure that I created a new variable rather than using the variable of the previous names. That being said, now I can take this crime data without header dot. Our input data is a string, and to convert into a data frame, first we have to get into a tuple, and then we can invoke a API called 2df. That's how we can actually convert into data frame. So to convert a string into a tuple, we can use map API. Okay, as part of the map, we are reading the each string as record from crime data without header, and then I can say rec dot split, comma is the delimiter, and the first field I want to have is date. Date is the third field, as we have seen earlier, and then I want to get the crime type, which is sixth field, which can be accessed as 5. We can get that information from the problem statement itself. So the third field is date, that's why I have used 2, and the sixth field is type, that's why I have used 5. Okay. Now to convert into data frame, I can use this function called 2df, and then to use 2df later point in time, we need to have SQL context, and when we launch Spark shell, SQL context will be available by default, and the name of the SQL context, or the variable which holds the SQL context, is SQL context itself. Okay, so that being said, we can actually give the names to each of the fields that are there in the tuple. So the first name I want to give it crime date, and the second field second name I want to the name to the second field I want to give is crime type. Okay, and now I can say crime data and the type df dot register temp table, and the name I want to give it is the name I want to give to this to the table is crime data. Once I have a table with this name, I can actually run SQL query using SQL context, SQL context.sql, select star from crime data, and to preview the data, I can use show command, which will get us 20 records. So let me copy and paste so far to make sure it is working as expected. Okay, and then I would also want to paste as temp table. And then I want to run this query to get the preview of the data. And you can see 20 records. And from this, I just need to extract this one and cast it into number. Means first I have to get year and then concatenate with month, cast it to number, and then I can club this. I can group the output with the result after casting along with the crime type, and I can get the count. So let us write the query. So instead of running select star from crime data, let me actually write the query. So to get the month, to extract the month from the date, I can use substring function or even substr function. And we have already reviewed that data is exactly in this manner. So I can extract this part first by using substring, and the index starts with 0. 1 means 7, 2 means the forward slash, 3, 4, 5, 6. From 6th character, I want to get up to 10th. Okay, so the from 7th character, I want to get till the 10th. So the beginning index has to be 6, and the starting from 6, whatever length I want to get, or up to whatever character I want to get, I have to give the exact index of that, which is 10 in this case. And we have seen that when we actually explore Spark SQL. So here I can say crime date, comma 6, comma 10, which will extract that 2007. And then I can say concat this value with substring of crime underscore date, comma, starting from first character, I want to get 2 of them so that we get the month. And I want to concatenate them together. And this will be the crime month. And we can preview the data by saying show here. And we can actually break this query into multiple lines. Okay. And let me run this query first to make sure that we get the data the way we need. Okay, this is not correct. I got it. So here I forgot the syntax. I want to get only 4 characters starting from 7th. So I think I have to give only 4 here. So that's why we have to preview immediately. And also I have to use 7, not 6. Starting from 7th character, I want to get 4 characters. I think I have misinterpreted this substring. Now we got the data the way we want. Okay. On top of this, I also want to get another field, which is crime type. Okay, and now let us see if I'm getting both date as well as type. Though it is not mandatory for the certification purpose, let us also see how I can typecast this from string to integer. By default, when I concatenate 2 strings, the output will be string. but the original data type of these values can be represented as numbers also. So the way you can do it is by using cast here, cast, and then as int. And now it is actually represented as number. Now I just have to group the data with the same logic and then get the count, and also I need to sort the data. So here again I am breaking into another line. Okay, group by this cast function, comma crime type. Also I want to add the aggregation function, count of 1, and crime count per month per type. Okay, and then we can actually run this query. So there is some typo somewhere. Let me figure it out. I have to put the space and then plus here, and then it should work. Now you see, we got the crime month, crime type, and crime count per month per type. But the output has to be sorted in ascending by order by crime month and descending order by crime count per month per type. And before saving, even the column names should be, first we have to get crime month, then crime count per month per type, and then crime type. So here I have to change the order a bit. Let me copy this and paste it here, and then give the comma here. Let me delete this and then do this, and then I have to say order by crime month, comma crime count per month per type, DESC. Now you can paste it and hit enter. Now you can see the data is in ascending order by month and then descending order by crime count per month per type. And also we got the data the way we want. Now I want to save this to file in compressed format. So there are multiple ways to do that. On the data frame, so this will actually give the data frame. If I remove the show here and assign it to a variable, val crime count per month per type df equal to, now crime count per month per type df is a data frame. Okay, and then I can actually copy this one, paste, then dot and hit tab. Okay, so there are different APIs to save. One of the API which can be used is either save or write. there should be right also. Okay, so using right dot and hit tab, there is a text API, and then you can give the path. But we need to give the delimiter as tab. So as we have to give the delimiter as tab, it is not very straightforward to use right dot text unless our data frame itself is of type string type. Okay, so to achieve that, what I can do is there are multiple ways to do that. On the same data frame, okay, there is some problem. On the same data frame, I can okay, actually, as part of the data frame, I can use concat on this thing, on these three things by nesting the query. So I can say select crime underscore month. Okay, and then I have to pass this to concat, and then I can say crime month comma tab, and then again I have to concat with comma crime count per month per type, and then again I have to concat this with tab, and then again I have to concat this with crime type. Okay, and then I have to say from plus, and I have to enclose this entire query in the circular brackets, and I have to give alias to this query, and I'm giving it the alias as Q. So this is how we can write. Okay, I can copy paste this one now. Okay, it is not liking this delimiter. Well, the easier way is to actually convert this to RDD. So let me go back and remove this concat by doing undo. Let me make sure that this query is running. Okay, let me also see the results. And as it is, as the problem statement is expecting us to write in delimited format with compression, what we can do is we can say something called this df dot RDD, which will convert the data frame to RDD. Okay, so to convert the data frame to RDD, we just have to say dot RDD, and then we can actually apply the map function. First, let us use take of 10 dot for each println to see how the data is represented in the RDD, and then we can come up with the logic. You can see data is represented in the square brackets. what I can do is I can apply the map function, okay, and then rec dot mk string, tab is the delimiter, dot take of 10 dot println, sorry, for each println. So make string typically takes something which is in the form of array and convert into string. You can see here, it actually converted the list of elements that are there as part of each and every record we have. As part of this new RDD created, we can actually check the data type of the RDD also. Okay, so for that, I just have to say, to get the output of this RDD function, we can just copy, paste here. So it is actually of each element in RDD is of type row. Row is nothing but a collection, and any collection have this make string function. And as part of that make string, we can pass a delimiter, and using that delimiter, it will actually convert the collection into a string. And that is what is happening here. Now I can use this, okay, and then save as text file. Let me get the path and other information from the earlier command, which I have used to save. And also let me have another session and delete already created file, because as part of the earlier solution also I have created the file. So I have to delete that. For that I can actually say Hadoop fs rm-r and give this path. Now I can actually copy, paste this one to save the final output into the location as per the problem statement. Again, it is actually running many threads to perform this task, and there will be 200 different files that we can see by actually running ls query, which we have ran earlier also. See, there are so many files that are created, and these are all small files. To address this issue, again, we can use coalesce of one, which will collapse many files into fewer files. In this case, I'm using only one. And again, before running this, I have to delete the existing path. So I'm running this. And now I am running the save as text file command once again. And it is executed. And now if I look at the output in the directory, to just perform the sanity check, we can see there is exactly one file, and even the size was same. If you closely follow, even previous time, we got the file of the same size. And we will actually validate the data as part of the next topic. So we actually got the solution for the same problem using CodeSpark APIs, and also combination of CodeSpark APIs, which are map functions, and then the SQL query using DataFrames or SQL context. This is how you can actually come up with the solution based upon your convenience. If the problem can be solved in either of the approaches, whatever you are comfortable with, go for it. unless it is explicitly said in the problem statements that you have to solve the problem in a particular way.